Hi everyone. Today we're going to go through some of the topics on the geometry test. So first off, let's start talking about our angle pairs. This is going to be the primary focus of this video here. So when we're looking at our different angle pairs, these are the ones that we've learned this year. So the first one is adjacent. One of the official definition for adjacent is it means it's two angles that share a side and a vertex. So if we look here, we have angle A, B, C, and then we have angle C, B, A, and they share side C and they share vertex B. That's that point right there. So that's the official definition. Another way you can kind of think of it is honestly, they're angles that are next to each other because more than likely, if they're next to each other, they're going to be sharing that side and that vertex. So these two angles, this one that's 22 degrees, this one's at 39 degrees, they are simply just an adjacent angle. They're next to each other. Another set of angle pairs is vertical angles. If two angles are vertical, they are opposite of each other. So when we look at this diagram, by having these two intersecting lines, the dark blue and the light blue, it creates four different angles. We have this angle here, we have angle A, we have this one, and angle B. Angle A and B, notice that they share a vertex, they have that center point, but they're across from each other. They're opposites. One way that I look at this is it's called vertical angles. And so when I think of that V for vertical, we have two V's that are put together and it, kind of makes an X, but we have two V's that are put together and that's what creates these two vertical angles. It's kind of like they make a vertical line, they're across from each other. And then one thing to note about vertical angles is they are congruent, and that's our geometry word for equal. So in this example here, let's say angle A was 50 degrees, then angle B, since it is a vertical angle, it would be congruent, it would be equal, and it would also be 50 degrees. Next up, we have angles that are a linear pair. When we look at that word, we can see the word line within it. These are a special type of adjacent angles because these two angles here, 1 and 2, they are adjacent because they're next to each other. They share this side, they share this vertex, but they are more specifically known as a linear pair because these two angles come together to form a straight line. And with linear pairs, what linear pairs are is they're supplementary angles. So you can call these angles linear or you can call them supplementary. They're synonyms, means the same thing, okay? And what makes something a supplementary angle is whenever you have a straight line measures 180 degrees. So that means angle 1 and angle 2, if they were added together, they make a straight line, which means they would add up equal 180 degrees. So in this example down here, it works because 60 plus 120 is 180. These two angles form a linear pair, which means they are supplementary and they add up to 180 degrees. This may be a little bit of a stretch, but I still think it's kind of cute and like to share it. If we look at the word supplementary, we can draw a line through the S and then it makes it like it's 180 degrees. A little bit of a stretch, but something kind of fun. And then the last angle pair is down here in the bottom left. That's complementary angles. So complementary angles are what we call adjacent angles that form a 90-degree angle. So these two angles here, they are considered adjacent because they share a side and a vertex, but they're a special kind of adjacent because they come together to form a 90-degree angle. And remember that whenever we have a 90-degree angle, we typically mark it with the little square in the corner. So this angle right here is 30, this is 60. They come together to make a right angle, which is 90 degrees. And we can kind of look at our word here for complementary, turn that C into a 9, and then looky here, we have 90 degrees. So last little thing before we move on is adjacent angles can be a linear pair. They can be supplementary. They can be complementary, or they could just literally only be adjacent. They don't have to be a special kind because 22 and 39 is not 90 and it's not 180. So you can have just plain old adjacent, regular, or you can have a special kind that, forms a straight line and is supplementary, adds up to 180 degrees, or you could have a special kind that form a right angle and equal 90 degrees. So let's do a couple practice problems here. So sometimes you can have a picture where there's lots of angles in there, so you kind of got to really focus in on it. So we need to decide if angle A and B are adjacent, vertical, linear, or none of the above. Well, adjacent means they're next to each other. They would share a side and a vertex, and I'm not seeing that here. Like if we had this angle marked, then that angle and angle B would be adjacent because they're next to each other. That's not the case. Next up would be vertical angles. So remember that vertical angles are when they are crossed from each other and they kind of share just that vertex. And if we outline this, that's what I see. These are opposite of each other. We can do that double V and it backs up side by side to make a little X. They're opposite of each other. So these are an example of a vertical pair of angles. And then if it was linear, they would have to be side by side and make a straight line. So in this case, in order to come up with a linear pair, we would have to include, we could call this C and this D, and it would have to be all three of these angles, B, C, and D, all together would make a linear pair. Or something kind of fun, you could have a linear pair that goes this way. C, D, and A would come together and form a straight line. So sometimes you maybe have more than two angles that come together to make a straight line and make a linear pair. But since the picture itself just had the two angles here, B and A, are across from each other, opposite of each other, they make vertical angles. All right, next up, what do A and B show here? Adjacent, vertical, linear, or none of the above? Well, I do see that we have a straight line here. That's kind of, not a very good straight line that I drew, but I do see we have a straight line. However, in order to get that straight line, I would need angle B, angle A, and this third angle. I don't have a third angle marked, so it's really just focusing only on A and B, which means even though I initially thought it would be a linear pair, we just ruled that out. All right, vertical angles, that's what we just talked about. Are these across from each other? No, it would have to be something up here in order for them to be across from each other. But they are next to each other. They are adjacent because they share a vertex and they share a line. A and B are right next to each other. So these are an example of adjacent angles. All right, let's do one more identifying one like this, because you may see some questions like this where, again, there's lots of angles present. I did label 3 of them, so let's first figure out what the relationship is between Z and Y. So what's the relationship between Z and Y? Well, I notice that they're next to each other, and they're next to each other and create that straight line. So these two angles come together to form a straight line, which means Z and Y together make up a linear pair. All right, let's change our colors now and let's see if there's a relationship between X and Y, which were the original 2 marked on this drawing. So if we look at X and Y here, they kind of look like they're across from each other, but they have to be across from each other and like make that X. They're pretty far apart. There's no double V. There's no X being made here, so I don't think they can be vertical. They're not next to each other, so they're not adjacent, and they'd have to be next to each other and on the same line in order to be a linear pair. So this would be an example of none of the above. These are not any of those three types. They're pretty far away. I don't see them as next to each other. They're not vertical. They're not linear. If just to round things out, we made an extra one here. Let's say we made this W. What would be the relationship between W and Y? That would be an example of vertical angles because they're opposite of each other. And if we do it, we have that double V, otherwise kind of known as, an X. It looks like an X together. So that makes a vertical set of angles. All right, let's start applying this to, using our knowledge, using what we know about angles to helping us find angle measurements. So the first thing is I want to find what the relationship is. And we could, start with whatever. I see that I have a 43-degree angle here. So I want to use that to see what's the relationship with B, and then what's the relationship with that in C to try to find the answer. Well, when I look at angle B right here, and then look at the 43 degrees, I notice that they are opposite of each other. I have a V on top and bottom, making that X, meaning that they are vertical angles. And vertical angles are congruent. And that's the geometry word for equal. That's the symbol, little equal sign with a squiggle on top. So if they're congruent, if they're equal, that means B would also be 43 degrees since B and 43 are vertical angles. Now, what would be the relationship between our 43 degrees right here and our angle C? Well, they're next to each other, so they are technically adjacent, but they're one of our special kinds of adjacent because they're next to each other and they create that straight line. So that means they are a linear pair. And if angles are a linear pair, they are supplementary, meaning they add up to be 180 degrees. So this angle C plus our 43 equals 180. So we know that C plus 43 equals 180 because they form that straight line. They're a linear pair, meaning they're supplementary. Well, how can we figure out that answer? Well, if we know that together they add up to equal 180, we could subtract to get our answer. So 180 minus 43 gives us a final answer of 137 degrees. All right, let's do another one like this. Note that I don't think I pointed this out earlier, so my apologies, but I have numbered it with the, question number that it matches up with the test. So if we just go back real quick, these first ones were all, examples of number 1 where you have to identify the angle pairs. And then this last one and this one are 4 where you have to take that and apply it to find missing angle measurements. All right, here we have a picture with lots of stuff going on. We want to find the measurement of 1, 2, and 3. I really look at this as a puzzle. So start with, something that you notice. So I see that I have a 37 degrees marked here. So I want to take the information that I know and see if I can find a relationship between any of the missing angles to get my answer. Well, I noticed that 37 degrees and angle 3 come together to form a straight line, meaning that they are a linear pair, which means they are supplementary, adding up to be 180 degrees. So we can take that 180 degrees, which is what we know they add up to equal, and subtract from that 37 to get our answer for the measure of angle 3. So 180 minus 37 gives us 143 degrees. Now I'm going to go ahead and label that on my picture because sometimes, like I said, it's like a puzzle where, one thing leads to the next. Once you get these pieces together, you're able to add another piece in. Sometimes you have to do that to get all of your answers. All right, there's a couple different ways you could figure out number 2. I'm going to use a different type of angle pairing so we can get a variety here. But I notice that if we look at angle 37 here and then angle 2, they're opposite of each other. They're across from each other. We take two V's, put them together, making that X. So 37 and 2 are vertical angles. And vertical angles are congruent. Vertical angles are equal to each other. So if this is 37 degrees, then that means angle 2 is also 37 degrees. All right, lastly, we need to find the measure of angle 1. Well, when I look at my angles here, I notice that 1 and 2 are adjacent. They're next to each other, but they do form a special kind. They form a right angle. So that means they're complementary angles. So 2 and 1 together add up to equal 90 degrees. So just like with the supplementary angles, we know that together they equal 90. So let's take away what we know, which is 37 degrees, and find that missing piece. So 90 minus 37 gives us 53 degrees. All right, let's step it up a notch, and still the same concept of using, our knowledge of angle pairs to find missing information. But on question 10, what steps things up a notch here is we have equations and not just missing numbers. So we have to use our knowledge of equations from last semester to help us out. So we're still going to start off the same, and we're going to look at the two pieces of information we're given. This angle is 3x plus 18. This one is 93. What type of relationship do these two angles have? Well, they are adjacent. They're right next to each other, but they're that special kind of adjacent where they form a line. So they're a linear pair, which means they are supplementary and add up to be 180 degrees. So I know that my 93-degree angle plus my other angle here, which is 3x plus 18, come together to equal 180. Because I have that variable and all that extra information, I can't just simply take 180 minus 93 and get the answer, because our question here wants us to find the value of x. But we can set it up just like I did here as an equation. This angle of 93 plus this angle of 3x plus 18 equals 180. Now we can solve this equation for x. So remember, when we're solving equations for x, the first thing that we need to do is do any simplifying. I don't see any parentheses, so there's no distribution, but I do have a set of like terms that I can combine, a 93 and an 18. So 93 plus 18 is 111 plus 3x equals 180. All right, I don't see anything else I can do to simplify, so now we can start solving. Remember, when you're solving, you're trying to get that x by itself, and to move things to the other side of the equation, you have to do the opposite. So we have a positive 111 here. So to get that over to the other side, we would subtract it from both sides. So 111 minus 111 is 0. We're left with 3x equals 180 minus 111 is 69. We have 3x equals 69. How do we get that x by itself? Well, currently we have 3 times x. The inverse, the opposite of multiplication, is division. So we'll divide both sides by 3, giving us x equals 23. And because this question just wanted us to find the value of x, that is what we have done. So we are finished. All right, let's do one more problem like this. All right, now we have a different angle here, but same set of directions. Let's use what we know about angle pairs to help us find the value of x. Well, when I look at my two angles here, I notice that they are adjacent, but they're one of those special kinds of adjacent. This time, though, they come together to form a 90-degree angle. So instead of us setting our equation equal to 180, we're now going to set our equation equal to 90, because I know that this angle of 63 plus this angle of x plus 12 is going to be equal to 90 degrees because they're a complementary angles. All right, let's solve our equation for x again, because that's what it's asking us to do here, find the value of x. Do we need to simplify it all? Yes, we do. We have a 63 and a 12 on the same side of the equation. We can simplify by adding, combining our like terms. 63 plus 12 is 75. Bring down everything else, so plus x equals 90. All right, now let's get x by itself. How can we get rid of that 75? Do the opposite, subtract it from both sides. So x is equal to 90 minus 75, which is 15. And looky there, my x is by itself, which means we are done. That is our answer. In order for these two angles to really add up to 90 to be complementary angles, our value for x has to be the number 15. All right, let's get to our last question here, and this matches up with number 6. It is our triangle inequality theorem. So I do have a picture up here in the right-hand corner to help explain, but we'll, go over it together, of course. So when we have the triangle inequality theorem, that's basically saying in order for 3 different sides to actually form a triangle, because you could have 3 different sides, like if you're thinking about, you're building something out of wood, or if you have, straws and you're doing like a little triangle on your desk or on a table. If they're crazy different lengths, it's possible that they can't really come together to make a triangle. Or if they did, it would look like this, where one of the sides is kind of sticking out. It's really going too far. Or one of the sides is too short and it doesn't end up reaching and matching. So in order for 3 side lengths to form a triangle, this is our theorem. It's essentially our rule to let us know, would this have, the right ratio? Would it really come together and actually make a triangle? Because one of the other things is, it's just to kind of give a little backstory, it's not just about whether they're the right length to really come together to form a triangle. They also have to be the right angle measurements. Because remember that the triangle sum theorem says the inside of a triangle has to be 180 degrees. So if you had 3 sides that came together, but it was a little wonky and it ended up only equaling 160, not really a triangle. It may have 3 sides, but something's a little off. It's not really right. So in order for the 3 sides to really come together and fit nicely to make a triangle, to really have an interior angle sum of 180 degrees, this is the theorem. This is basically the rule that we can follow to check that. And the reason it's called an inequality theorem is we have these inequalities right here. This rule tells us that if you take any 2 sides of a triangle and add them together, that value is going to be greater than the 3rd side. So if we kind of look at this picture here, it's saying, okay, if we take side A and B and add it together, it has to be greater than C. But because the rule says any two sides, you have to do all possible combinations. So A and B have to be greater than C. But what if you picked a different two set of sides? What if you picked A and C? Well, A and C have to add up and be greater than B. Well, there's a third combination. It's kind of like if you're playing video games and you have a lock that you're trying to get into, you have to maybe try all these different combinations until you get the right one. Same here. We have to come up with every combo of two sides. Thankfully, since it's a triangle, there's only three combinations. So then the last one would be if we added B and C together, that would have to be greater than this third side. So let's do that here with these three side lengths. We want to know, would these form a triangle? So because it, could be easy to forget which ones you've added, a couple things I want to, that I use to help me remember is one, I know that I have to test this 3 different times. And to make sure that I'm testing 3 different sets, I just personally always go in this order because it just is easier for me and helps me know that I'm doing, the right thing. So I always, first off, just add the first 2 numbers together, make that my first 2 sides, and see if they're greater than the third. So if we add 2 and 15, it needs to be greater than 16. Well, 2 plus 15 is 17. That works. All right, so the first one works. But because the rule said any 2 sides, I have to check the other combos. So the second combination I always do is then I choose the last 2. So 15 and 16 need to be greater than 2. You're going to get to problems like this where you're like, I really don't even have to add those. I know that 15 plus 16 is greater than 2. I'm going to go ahead and still add them just to show my work. But there will be times once you get the hang of this that you can be like, oh yeah, I know that one works. Move on, try the next one. So if I add these, I get 31. 31 is obviously greater than 2. That works. So now for our third and our final set, I then take the first one and the last one and add those together. So 2 and 16 need to be greater than that third side of 15. Again, this one's kind of obvious, but if we still add it, we can see 18 is greater than 15. So that means because we got a yes for every possible combination, these 3 sides would, in fact, form a triangle. All right, let's try one more like this. All right, what if we have the sides 3, 6, and 2? So once again, if I want to know if they form a triangle, I'm just going to start with my first 2 here, add them up, see if it works. So 3 plus 6 needs to be greater than 2. 9 is greater than 2. Yep, that one works. Now let's add up the last 2 sides. 3 plus 2 needs to be greater than 6. Well, 3 plus 2 is 5. Is 5 greater than 6? No, that did not work. As soon as you get the answer of a no, you can stop showing your work because if one of the sets doesn't work, doesn't ring true, then these 3 sides could not form a triangle. It's impossible. So I can just stop right here because this combo doesn't work. Something, maybe one of the pieces would be a little too short. So your triangle would look like this or something. It doesn't actually close the gap and come together. So it would not make a triangle in this case. All right, well, hopefully this helps with all of your guys' questions. Hopefully clears things up about those angle pairs and the triangle inequality theorem. If you have any other questions, just let me know. Thanks. Bye.